So we just finished talking about, he says that you're going to make forecasts for 24 months into the future. And so let's just look at those pictures, 5.3 through 5.6, just to see what he's talking about. So there. Okay, so here's, we go all the way back to 1950, but here's 24 months into the future. Starts here, and this is what it says the pattern is going to be. And then we also have what we call a confidence interval around there. In other words, we say, we predict like in here, but we say it could go up to about here and down to here, given a certain level of confidence, like 95% sure that it's going to be in this range between here and here. And of course you can see that as you move to the right, the spread of our prediction gets bigger. So here, when we get all the way to the end, there's a big spread all the way from top up here all the way to down here. And that makes sense because we have more uncertainty as we predict further into the future. And this is the same thing. Here you can see that prediction and then the confidence interval around the prediction, and you can see it's getting wider and wider and wider as you move to the right. And you can see the same thing for this. This is consumer sentiment, and this is new homes sold. So we do it for each economic measure. So he says that forecasting uncertainty is there's uncertainty there, and that's reflected in the gray area around the forecasted values. And we see from these economic forecasts there's much uncertainty about the future, and the further we look into the future, the greater our uncertainty. Notice the megaphone effect in the figures with a wider prediction interval further into the future. The value of a model lies in the quality of its predictions. We have work to do with these forecasts. So each of those pictures were a single economic measure, and then he says what we can do next is we might try to fit a multivariate time series, or what's called vector autoregressive VAR model to our 4-time series. Or we could explore what's called dynamic linear models, regressing one time series on another. So we use one of the variables as input to forecast the other, and that's we've done that. I think we've talked about that in general for regression, and here we'd be doing it. The input would be a time series, and we could utilize ARIMA even there, and that package that we use actually allows us to do that. ARIMA transfer function models, or state space models. Basically that means using a input of a time series and also output of a time series, but that makes it sound complicated. Using using consumer confidence to predict employment rate, right? Just a typical thing, but both of those are time series, so we have a special name for it. The possibilities are many, as are the modeling issues to be addressed. Okay, now here, this is a very good note, and I think we should talk about it. A very good footnote. So he distinguishes between time series regression and time series analysis. So let's see what does he mean by the difference. So time series regression is when we're taking several variables and trying to predict a time series variable, or a time-dependent variable. So we're using time, but we're also using other variables. On the other hand, when we're talking about time series analysis, we're not talking about, that's different than time series regression, and we're talking about methods that start by focusing on one economic measure at a time, like we've been talking about so far here, and its pattern across time. So that's what we were looking at in all those graphs. We look for trends, we look for seasonality, we look for any kinds of cycles in that individual time series. So just going to the picture for a second. So like one of these. So here we have just one. This is, what was this? National housing starts. So this is just one variable over time as it changes over time, right? Another variable as it changes over time. So we just look at one of these, and we can look for seasonality. Now here it looks like there's a lot of seasonality. So like I guess that you can see this pattern goes up, down, 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 and then up, down, 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 down. That's probably happening over a year. So that's called seasonality. There's, things happening maybe in the summer. People start building more houses or something like that. So that's seasonality. And there might be other cycles as well, not just seasonal cycles. And there's a kind of trend here going up. Of course, that trend starts going down, but we can talk about a trend as well. So those are the kinds of things we talk about when we're talking about time series analysis, not time series regression. So we look for trends, seasonality, and cycles in the individual time series. Then, after working with single time series, we look at possible relationships with other time series, with another variable that is time dependent. If we are concerned with forecasting or predicting the future, as we often are in predictive analytics, then we use methods of time series analysis. Recently, then he mentions this, something about what's called state space models for time series, which provide a convenient mechanism for incorporating regression components into dynamic time series models. So you can look up these references, and you can look up what's meant by state space models. So that was an important footnote, I think. And then finally he says, similar to other data with which we work, so we've been talking about other things in our class, but now we're working with economic data. Economic data are organized by observational unit, time, and space. The observational unit is typically an economic agent. So we're talking about, we usually study an individual, or we study a company, or even a country. So those are called the observational units that we're using. And then we measure those observational units using usually financial means, but not always, across time and space. It is common to use graphical analysis as a basis for aggregation. Alternatively, space, longitude and latitude, can be used directly in spatial data analysis. Time considerations are especially important in macroeconomic analysis, which focuses on nationwide economic measures. So that observational unit would be a country, for example. Okay. Here he gives us a review of the literature, which you can look up these references yourself. For gathering economic data, we build on the foundation R code provided by Ryan, useful for programming with dates. Our R functions provided by these guys. Wickham is a very important guy. Anyway, we will need to work with functions, R functions that are used for time series. And then here he says finally, the Granger test of causality, a test of temporal ordering, was introduced in the classic reference by Granger in 1969. The interested reader should also check out a delightful article that answers the perennial question, which came first, the chicken or the egg? Okay, so let's take a look at the code now that we understand the background.